When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to the past HSC exam question videos from the acidic and pH scale chapter. While doing the second, I'll read the actual question. Once I've read the question, give about 5 seconds to pause the video. Once you've paused the video, attempt the question, and then press play when you're ready again. The question itself says, calculate the pH of 0.2 moles per liter solution of hydrochloric acid. And the second part was, calculate the pH after 20 mils of 0.01 mole per liter of sodium hydroxide is added to 50 mils of 0.2 moles of hydrochloric acid. Include a balanced chemical equation in your answer, and that's worth 3 marks. So when you're ready, press pause and attempt the question. Welcome back. So the first one is pretty straightforward. All we have to do, we have to use our normal pH equation. That would be pH equals minus log to the power of the concentration of hydrogen ions. In this case, because we've got hydrochloric acid, we know that hydrochloric acid completely ionizes, so whatever concentration of that we have is also our concentration of hydrogen ions. So all we have to do is we have to type in this concentration of hydrogen ions into the H plus here. So equals minus log of the concentration of 0.2, and if we put that in the calculator, we would get a pH of 0.7. Now I can't do that because my calculator isn't good enough or isn't advanced enough to do logs. But yeah, if you just type in minus log to concentration of 0.2, you will get 0.7 pH, and that would be your 1 mark that you get for this. Now this is worth 3 marks. Next question B. And it says we need to include a balanced equation. This question actually comes from 2 chapters. It comes from this chapter, from the pH scale chapter, but also from the next chapter. So if you're a bit confused by this question, that's okay, because some of the parts will be mentioned in the next chapter. But I go through it anyway. So it says include a balanced chemical equation, that's worth 1 mark, and figure out the new pH after a base was added to the acid, and that's worth a mark as well. And the whole base and acids being neutralized, all that stuff will be covered in the next chapter. We'll do the first part first. So a balanced chemical equations. We've got hydrochloric acid, that is here, that's our acid, and that is aqueous, is added to our base, which is sodium hydroxide, and that's NaOH, and that's also aqueous. Those two will turn into a salt called sodium chloride, which is also aqueous, and 1 mole of water, H2O. And this is called a neutralization reaction. But yeah, you're going to cover those neutralization reactions more in the next chapter. Right, so that's the first step. That will get you 1 mark, just for that balanced equation. And then what you need to do is you need to figure out how many moles are in 20 mils of 0.01 mole, how many moles of hydrogen ions so that's 20 mils of sodium hydroxide. So we have to figure out how many sodium hydroxide ions are in 20 mils of 0.01 molar of sodium hydroxide. And we also have to figure out how many moles of hydrogen ions are in 50 mils of 0.2 moles per liter of hydrochloric acid. And how we can do that? We'll do the acids first. So it says we've got 50 mils of 0.2 moles per liter of HCl. So per liter it has 0.2, but we only have 50 mils. So how many moles do we have? Well, in that case, all we have to do is times 0.2 times 0.05, because remember, 1 liter is 1,000 mils, but we don't have 1,000 mils, we only have 50 mils. That's why we times it by 0.05 to actually get the amount of moles we have. And if we do that in the calculator, we will get 0.2 times 0.5 equals 0.1. So we've got 0.1 for this. Sorry, 0.01. Should have been 0.01. 2 times 0.05 equals 0.01. I must have made a mistake initially, but yeah, 0.01 moles. So we've got 0.01 moles of hydrogen ions from the hydrochloric acid. And if we do the same thing with our base, we've got 20 mils of 0.001 moles per liter of sodium hydroxide. So how many hydroxide ions do we have? Well, in this case, we do 0.01, that's our concentration. That's per liter. So we've got 20 mils, which is the same as saying 0.02. And then we have our concentrations of hydroxide ions. So we do put that in our calculator. 0.001 times 0.02 equals 0.00002. Is that correct? Yep. So that's our concentration of hydroxide ions. So that's how many hydrogen ions we have, and that's how many hydroxide ions we have. But we want to figure out the pH. That's what it's asking. Remember, the pH was just the amount of hydrogen ions we have. So we don't really care about hydroxide ions, but the one reason we do care about hydroxide ions is because they neutralize hydrogen ions. The more of this we have, the less hydrogen ions we have. So 1 mole of hydroxide ions will neutralize 1 mole of hydrogen ions. So what will actually happen is we have to minus this. We've got 0.01 moles, and we have to minus it by 0.00002. And the reason why is because those hydroxide ions are taking away our hydrogen ions. So that's why we're minusing this here. So we've got, initially we had 0.01 moles of hydrogen ions. Now we have to minus that by 0.00002. And then we have left over 0.0098 moles. So this is what we have left over. We've got 0.009 moles of hydrogen ions. And now we're almost done, but we still have to get the concentration. So our concentration of hydrogen ions, that's what we want to have. And then we're close to being done. And how that works is we've got our number of moles, 0.0098 moles. And we've got the volume that we have, because it says 20 mils and 50 mils. That's those two added together is 70 mils. So if we type 0.0098, that's the moles we have, divide that by our volume, divide that by 70, equals 0.00, oh sorry, not by 70, 0.07, because it's in mils, so we have to turn it into actual milliliters first. So it should be 0.0098 divided by 0.070 equals 0.14. So our concentration per liter is 0.14 moles per liter of H+. And now that we have that, we have to just put that number into our pH equation, so this one here. So if you type in minus log the concentration of 0.14, what you'll get is 0.85. So you have a pH of 0.85, and that will get you your answer. So you get one answer for the correct equation, and one answer for the correct answer, and also a 1 point for the correct way to get there. Yeah, sorry that I might have done this a bit confusingly. I got confused a couple of times because I didn't do the proper way of making it into mils first. But yeah, hopefully you can still get something out of the video. But yeah, sorry about the slight confusion. But yeah, these questions came from 2 different chapters. So from the next chapter and from this chapter. So if this question wasn't completely confident, that's okay, because you're going to bit of it in the next chapter as well. Hope that was useful.
Thank you for watching.